Hello everyone, welcome back to our math class. Today in this video, we are going to talk about exponential function. And this video will be considered as an introduction for this type of function. In this video, we are going to look at the expression of the exponential function, and we are going to use a table to figure out how the graph of the function looks like. And also we are going to analyze a little bit basic features of the function. So this lesson is more like introduction for this fundamental things of exponential function. So before we jump into the exponential function, I want to look at the two tables here, and we can compare how the linear and exponential function look like by presenting the tables here. So the first one, as you can see, if you look at closely for the tables, we notice that as x increasing by 1, y decreasing by 3. So as you can see, the average rate of change for the first function is actually -3 because it goes consistently by going down by 3. So it's like you're going by steps here is consisting going by 1. So that's actually give us a model of a linear function. However, the second one, as you see, when x is increasing by 1, but y, instead of adding or subtracting, is actually multiplying by 6. So that's why the second model is increasing by this way. So that's why it's actually represent the exponential function. So the first one is linear model, but the second one is exponential model. So y increases very, very quickly and is not consistent, is not constant number for the rate of change. So that's this one. I just want to give you a quick example regarding how the linear and exponential function looks like in the table, and how the number changes and how the number pattern changes based on two different type of function. For the major part of this video, we are going to discuss how the exponential function looks like, and we are going to create a graph, and we are going to analyze some features here. So as you can see, the exponential function, the general form is actually written as a times b to the x power. And the reason we actually call this exponential function because the variable x here is located as exponent. So that's why we call this as exponential function. And we are going to look at the two examples here and to see how the exponential function looks like. So the first example is very straightforward. I just create a y to the 2x power, and in this case, as you can see, a is an invisible 1 multiplied here, so a is 1. Because you do not see the number here, that means it's 0, because 0 times everything is going to be 0. So there's no way we can just get a 0 as a constant, right? So a is 1, and b is considered the base in this case. So b is 2 for this one. And you can see the second example I gave you here is, sorry for this one. So is 1/2 to the x power. So for this case, then it's going to be, so the a will be 1, still invisible 1 multiplying in front of this, but b, the base, will becomes 1/2. Okay, so the first function, the first part, we are going to use a table. We are going to create a table based on the expression of the function. But as we mentioned before, whenever you talk about function, very easy to demonstrate function by using the equation and by creating table, and also we can check the graph. That's a very basic three ways to represent a function, and that's how we visualize and make a connection between each part. So let's check the table. A list of the x value are given, and we just use x value to plug into the equation to get this. So to make it easier for you, I list all the possible ways to do this. Not really possible way, it's just how we get the value of y. So as you can see, the x represent the exponent, so we just, based on the value are given, we just go 2 to the certain number of the power. So let's just quickly write down the answer here, and that's how we get the value of y. And after we do this, we can just easily plot all the points here. For example, the first one represent -1, -2, -1/4. So this is actually the value here, so it's actually represent here. Once we plug all the points here, we can just connect them, and you notice that at the beginning of the part is actually increasing very slowly, but once we go beyond 1, is the function increasing very, very quickly. That's a big feature of the exponential function. So that's one part of that. And second part, the base becomes 1 over 2. So let's just quickly write down the value here. By the way, whenever we work on non-zero number to 0 power is 1. And this actually follow the rule for that. So this is how we get value here. And again, once we plug all the values here, you can see there's also a curve, but this curve actually pretty going down here. So now, let's quickly check the graph here because this graph is actually quite interesting. First of all, as you can see, it's a curve. It's not like a straight line like we mentioned the linear function before. And also, if you pay attention for this piece here, this part. So this part, as you can see, if you extend it like zoom in part of the graph, you notice that the curve is closing, is getting closer and closer to the x-axis, but it will never touch the x-axis. That's a very important feature for the exponential function. So that's why we use the word, the graph is approaching. It's like approaching to the x-axis, but will never actually touch the x-axis. That's a major feature for here. So for the domain, as we mentioned, is everything about x. And there, as you can see from the left to right, it's actually no break, no open circle, anything like that. So we consider it's all real numbers for the domain. And also we can just use a negative infinity to infinity to represent a number line, meaning every single number on the number line has a definition for that. But if you pay attention to the graph, like vertically from the top part to the bottom part, you notice there is no bottom part of the graph under the x-axis, which means y, which is the range here, is greater than 0. In other words, is 0 to infinity. Again, the reason we didn't say greater than or equal to, because the y, the graph is approaching to x-axis, but it never touched it. That means y can never be 0. Same thing for here. We are going to quickly write down the domain for this. Again, this every single x value on the number line has a definition. There's no break for the graph. But for range, again, we do not see the bottom of the graph here. There's no graph, right? So that's why y is only 0 to infinity. That's just two ways to write it. Okay, so also another feature I want you to pay special attention is if you check the graph, if you check the graph from the left to right, you can see this one is increasing, but this one is actually decreasing, right, from left to right. And if you pay special attention here, is actually what part is actually making happen is actually coming from this number, the base. When the base is 2, it's increasing, but when base is 1 over 2, it's decreasing. So we can generalize this feature by summarizing like this. If we just have y equal to b to the x power, like a simple form like that, when b is greater than 0, it's increasing, but how do we call this? We call exponential growth. But if we are talking about when b is less than 0, but, not less than 1, meaning number between 0 and 1. The reason we call this because we need to keep the base as positive. So if you have the base between 0 and 1, like 0.5, 0.3 to the x power, then it's actually meaning decreasing. And this will be called exponential decay. So for this case, this one is exponential growth, and this one will be exponential decay. Okay, so that's the difference here. And the reason we talk about these two models, because when we talk about the real life examples here, for example, you purchase a house, but you sell the house, generally speaking, the price of the house is going to be increasing. Or if you save the money in the bank, you earn interest, the value of the money is also increasing. So that's a model we can use exponential growth to model. And for a real life situation, for example, you purchase a phone, but you're going to sell it later, or you purchase a car, you're going to sell it later as a second-hand phone or car, the value, generally speaking, it will be reduced, will be going down. So that will be the situation we will use exponential decay. So that's just two different models we can analyze Okay, that's just quick lesson. I just want to share with you some basic features of the exponential function. Thank you so much for watching and study this topic with me. See you soon, everyone.